Hello everyone, this is your friend Jean. Do you want to learn something interesting? Okay, let's start. Our discussion for today is all about quantitative analysis and interpretation under the levels of measurement. But before that, here's our objectives for today's video. At the end of the discussion, the student should acquire at least 75% proficiency level and must able to define the levels of measurement and determine the levels of measurement. So what is the levels of measurement? The levels of measurement, also called scales of measurement, it is to tell you how precisely variables are recorded. In scientific research, a variable is anything that can take on different values across your dataset. Such examples are your height or your test scores. So let's dig deeper. Nominal, ordinal, interval, and ratio level. Going from lowest to highest. The four levels of measurement are cumulative. This means that they each take on the properties of lower levels and add new properties. In nominal level, you can categorize your data by labeling them in mutually exclusive groups, but there is no order between the categories. Examples of nominal scales: city of birth, gender, ethnicity, car brands, and marital status. In ordinal level, you can categorize and rank your data in an order, but you cannot say anything about the intervals between the rankings. For example, although you can rank the top 5 Olympic medalists, this scale does not tell you how close or far apart they are in number of wins. Examples of ordinal scales: top 5 Olympic medalists, language ability, beginner, intermediate, fluent. Liker type questions, very dissatisfied to very satisfied. In interval level, you can now categorize, rank, and infer equal intervals between neighboring data points, but there is no true 0 point. The difference between any two adjacent temperature is the same, 1 degree, but 0 degrees is defined differently depending on the scale. It doesn't mean an absolute absence of temperature. The same is true for test scores and personality inventories. A 0 on a test is arbitrary. It does not mean that the test taker has an absolute lack of the trait being measured. Examples of interval scales: test scores, your IQ or your exams, personality inventories, and temperature in Fahrenheit or Celsius. In ratio level, you can now categorize, rank, and infer equal intervals between neighboring data points. And there is a true 0 point. A true 0 means there is an absence of the variable of interest. In ratio scales, 0 does mean an absolute lack of the variable. For example, in the Kelvin temperature scale, there are no negative degrees of temperature. 0 means an absolute lack of thermal energy. Examples of ratio scales: your height, age, weight, and the temperature in Kelvin. So now, let's proceed to the importance of the levels of measurement. Why are the levels of measurement important? The level at which you measure a variable determines how you can analyze your data. The different levels limit which descriptive statistics you can use to get an overall summary of your data, and which type of inferential statistics you can perform on your data to support or refute your hypothesis. In many cases, your variables can be measured at different levels, so you have to choose the level of measurement you will use before data collection begins. That's all! Thank you for listening, and to test your knowledge about our discussion, we will have a quiz in the comment section. Bye!